Thanks for letting me know that I just started a stream, y'all. Now, the first thing that I would like you to look at is this video, and I watched it a few years ago, but I just looked now and it says that it was put up a year ago, but I saw this a couple years ago and I remembered it, did not forget it. And I'm probably going to show you this again as I compare notes. Okay, this is the first thing that I want to show you. I will compare notes later and I will show you again. this is the first thing that I would like to show you on my theory. It's based on factual information, and I've been researching it since about, ongoingly researching it since about 2005. I had some information that I was researching earlier than that, but since 2005 I've gathered some information, and I'd like to show you briefly what I'm talking about. So here we go. Go back to it and next thing that I would like to show you is about global conveyor belts. You can kind of research it on your own, but basically there's a pattern in a way that the wind and air and water and the way the atmosphere interacts with heat and light and UV and cold air, etc. It all kind of boils down to the global conveyor belt. Okay, so here we're going to look at ocean circulation. Now, this is specifically how cold and warm air and the ocean currents move and historically have moved. I get it. Ha ha ha. Sorry. Technical difficulties. Okay, so here you have the planet of Earth. And these are the way that the currents move. I'd like to bring your attention to the North Atlantic Gyre and also the North Pacific Gyre, and part, we'll say half of the South Pacific Gyre, because I'm specifically talking about certain areas. Okay, so Okay, so as you can see, the North Atlantic Gyre comes from the Gulf Stream. Here's the Gulf of Mexico right here. And, excuse me, kitty, I'm trying to do something. Can you be quiet? Okay, so the currents travel this way, up, 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 towards the UK right here. Okay? And then here we have the Yellow Sea. And a lot of the as you can see, the Kuroshio current takes a turn right here at the Yellow Sea and the Bonhai Sea, which is just a little bit inland, okay? What? No, I can't get it. What are you doing? Okay, so we'll go back to that. Now, I'd like to show you the current weather in the United States. As you can see, there's a little bit of supposed rain here near Los Angeles, but I think it's pretty clear out there. And then you see this warm front moving up from the Gulf of Mexico towards the northeastern part of the United States. Okay, so normally, alright, and here we've got the gyre that comes in here from the North Pacific, okay? So it brings in warm air here, and then right about here it kind of picks up some cold air, and it's not warm, it's warm, or, well, warm and cold mixed together here, and that's a good reason why Seattle gets a lot of rain, okay? Seattle's up here, somewhere up there. Okay, so then the South Pacific Gyre meets up with this North Pacific Gyre gust, and it brings, like right around here, there's an arrow right around there, and it meets just about this area, and then wind, current, and weather is always going from west to east across the United States, like this. You can see that there's I think they'd call that like a clipper or something, where it's kind of pushing up, and over to Maine is up here. Okay, and then after this storm system leaves the United States, it gets on that North Atlantic Gyre, and it goes over here to where England is, and the UK, okay? Okay, so next. Let's show you this again. And this is very important for the way that the weather systems and even erosion of continents and such things like that. Okay, so here's the UK, and here's the Gulf Stream, and here goes the North Atlantic Gyre. Okay. And here's Los Angeles. Los Angeles here, and the North Pacific Gyre comes along and brings weather here, and it goes like that. And then this little guy here, what is this? The Alaskan current kind of pulls air here, and it brings it down. So it comes down this way, and it kind of meets up right in this area. So there gets a lot of wind in this area because of that. Okay. And then back over here, and you see that that goes almost directly, and you can think of it like you play pool or something like that, like on a pool table. So it goes like this, and it hits the UK right here. So this is the UK. And then it brings air down, and then the cold air here comes down with it, with the Canary current. Now the thing about weather in the United States is normally it doesn't behave so much like this. Like, it's moving very fast up from the Gulf of Mexico. That's not really normal behavior, but over the past, I don't know, decade, it's becoming more and more normal. And as that's happening, parts of, Louisiana, the Everglades, things like that, they are eroding away, which is also some man-made reasoning, but a lot of it's the weather, okay, and that's happening in this area, so it'll bring a lot of flooding with it, and with it, weather, which is where the flooding comes from, is the rain. But normally, oh, and also I noticed since I moved to Los Angeles, this is where I live now, I used to be from up here in Cleveland, is a lot of the time, now, weather's always supposed to move from west to east across the United States, but some of the time, a lot of the time, I've noticed that the clouds come up here, and you can never really see this on a radar map, but the clouds are going the other way. They're going from east to west, which is strange behavior, and it comes up and over, and then it kind of gets rolled up in here again, and then it kind of sometimes makes its way back, which is what you see here. So basically, what usually historically happens with weather in the United States is that, and we're not talking about Mexico, we're just talking about United States and maybe this little part right here, Baja Peninsula. Okay, so normally air comes up here, and it's also coming down here at the same time, like in that little curve, like in the same ratio as this curve right here. This is the exact way that the wind moves, and that's what shaped this like this. So it comes down like this, and then it meets somewhere around here. Okay, I'm really nervous about this. Okay, so then, in the meantime, this weather's coming over here, and it's moving across the United States like this, and then this will move this way. And then, in the meantime, some of the Gulf air kind of circles here, which is why, you know, like some of these areas here get hit with tropical storms a lot, okay? Like that's why, because of the warm air circulation, a lot of it being right here, some of it being down here, but some of it being up here. And it also creates a vortex where it's pulling air into it, okay, and pulling weather into it at the same time. It's like almost like a vacuum, okay? So this is moving with that, and that's what helps it to pull from the Los Angeles area over this way, and it gets sucked up in it, but it's far because it's over here. So what's going on is it's going like this up towards these states, which is like Pennsylvania, Ohio, parts of Ohio, like northeastern Ohio, and up to Maine. And in the meantime, there's kind of like a light draft that comes in from Canada, and it comes down, and it clips right here, which is what creates lake effect snow in the Great Lakes, okay? So that's doing that, and that's where the weather up here tends to come from, is from here and from up here. Okay, so this area is coming along here. This is how this normally works, okay? But now it's coming up here, which means that the trajectory is somewhere over in this area, which is strange that there's no rain coming to these areas, which are suffering from a drought, okay? Mexico's not really having too much trouble from what I've seen with drought. They get a lot of rain in Mexico City, which I don't think is flooding them, but it's like making lush greenery. But I think maybe, I have to look into it, but I think maybe they're getting a lot more rain than they used to. But it's possible that they're getting about the same amount because of the way that the weather would hit. Okay, so, sorry. Back to this. Okay, so it's coming over here, and it's pushing, now it's just pushing this stuff over, like in that straight line here. But the weather's coming from down here and moving upwards, which is not normal. So normally what it would do is go over and then start pushing up this way, and then it would move its way over to the UK. And the UK is being flooded. There's so much rain, which they have a lot of rain, but it's more rain than they normally get, which is causing erosion, which is making flooding even easier, because it can just kind of like soak up from the ocean, because it's a very small, you know, set of islands there. Okay, so now I'm going to go back to play it for you again. You're saying, what does this have to do with anything? Okay, let's look at it a little bit closer so the light's not. Okay. So now you're looking at a wind turbine, and here is the, I don't know, what do you call it, a propeller? I don't think that's what it's called. Now, as here, it's just swept across counterclockwise. Here is the propeller. Here is a vortex. You show it here. These are voids formed by vortices. Vortexes are transported downstream. Okay. So then, these are chaotic vortexes and vortices. And you can see them spinning, and they almost look like little tropical storms or hurricanes. But these are very small. They're like, excuse me, approximately, I don't know, this is a few feet across maybe, the center of this. And these are spinning, and what it is doing, essentially, is weakening the air current. So, where they put wind farms in a place that gets a lot of wind, the wind that goes through those areas gets weakened by the wind turbines, windmills. Okay, so I did a little bit of research. I've been paying attention to the weather, the droughting, and the strange behaviors up here, as well as in the UK. And basically, what I am getting at is that here, in this area alone, of Texas, there are four of these four are of the 50 largest wind farms on the planet, okay? And they're here. And then, let's go back to the map. Let's go to Google Earth. Okay, so 4 of the 50 largest wind farms in the world are right here on the Gulf Stream. Or, I'm sorry, on the Gulf of Mexico. And which happens to be where that weather system is coming from. And another, coincidentally, 4 other of the 50 largest wind farms in the world are in Inner Mongolia, which is right here on the Bonhe Sea and the Yellow Sea here. Okay, now the make sure I'm saying it right. Okay, so here, this warm air comes here, it gathers all kinds of yellow sea weather. And it brings it across, over to specifically Los Angeles, where I am from. And hold that thought. Then the weather moves across the United States and up, up, up. Here's the North Pole. Up, up, up to the UK. So there's 4 of the world's 50 largest wind farms here. Excuse me. And similarly, 4 of the world's 50 largest wind farms in this area. So this weakened wind that you saw in this watch it again. Okay, so the weakened wind from the wind turbines plays a part in all this. When it comes over here, it's much weaker than it normally is when it hits the United States here around Los Angeles. But what is actually happening is that this, the North Equatorial Current, sorry, and the excuse me. Okay, so this is pulled into this, and this is released into this. So the equatorial countercurrent is taking a turn here that it normally hasn't in history, and it's taking a turn here, and it's moving up in the United States. And what this coming up this way is doing is when weather is clipping this way, it's getting pulled into a vortex here where it meets. Okay, this is spinning. This comes across. This would spin into this. Part of it would, and like the jet stream. Okay. But what's happening is this is coming up this way, spinning into this, and this is coming over this way, spinning up and spinning into this. And then what happens, I don't have better lingo, sorry guys, what happens is that That creates weakened weather, which picks up rain, additional rain, as it goes across the North Atlantic Gyre and the North Atlantic Current. And when it gets to the UK, it's got substantially more rain in it. So, there you have it. And let me... let's look again at this. And again, earlier in the video I said that clouds and storms have been moving west to east, which isn't normal. They've been moving this way versus this way, which is normal. This appears to be normal at the moment, but it never shows on maps when it's going this way, because what it does is it kind of goes this way and then it comes back up. This way, comes back up. Okay, so it goes across the United States, but what I was saying is that it's coming up here with the counter current. And the wind associated with the counter current. Okay, now let's talk about you guys had another interactive map here. Anyways, so as you can see, the jet stream kind of moves this way over. It's not supposed to go this way, but what it's having a tendency to do is clip here, move up like that, rather than like this. So basically the weather that usually goes here and up towards North America would, northeastern United States, it would come straight across, but what it's doing here is going up and over directly to the UK, not across, but up and over. See if we can find something better than this. More interactive. Or even let's look at images, okay? Now you see how this is kind of wiggly and this is not so much. So let's look at this Hubble map. You see how it pulls it right up here instead of, can I make this bigger? I can. Okay, so this weather is coming from over here, Yellow Sea, coming across. Oh wait, no, that's the United States, okay. So Yellow Sea's weather is coming up, moving over this way towards the United States, and then that's moving across up to the UK. Let me see if I can get some NASA Hubble just to kind of sink this in, because this is very important. This is going to cause all kinds of storm problems. This is going to cause all kinds of erosion and flooding. And it's due to the weakened weather from wind turbines. Let's see, what is this? I forgot to look this one up. Alright. Well, I'm gonna leave it at that. But, one last thing is this is all due to this is all due to air induction. There's a map here. So that's my completely unrehearsed spiel on what's causing a lot of weather problems, and it's not just global warming. Thank you for watching.